Hello everyone, welcome to the ITLS Academy. Today we are going to perform an experiment that is determination of the protein in soft drinks. Okay, and the method that we are going to use for the determination of the protein in a soft drink is Lowry's method. So we have a sample that is your soft drinks in which we are going to perform the experiment that is determination of the protein. So before starting our experiment, we have to know that the basic of the protein. We all know that what is the protein are and why these proteins are important. So the first thing is that what is the protein? Simply, protein is made up of the long chain of the amino acid. Okay, you can say that the amino acid is the building block of the protein. This amino acid is the building block of the and this protein is come under the category of the macronutrients, means that it is required in a huge amount to the human being so that they can complete their day-to-day work. Basically, this protein provides the energy to the human being. Okay, if you take 1 gram protein, then it provided around 4 kilocalories. So this protein very similar to the carbohydrate for the providing of the energy. Okay, at the point of the providing the energy to the human being, this protein and carbohydrate are provided the same amount of the energy, that is 4 kilocalorie. Uh, 4 kilocalorie. Now, macronutrients means that our body required protein in a huge amount. So, this is a basic definition of the protein. Now, we have to move forward towards the importance of the protein. Now, these proteins, there are several importance of the protein. The first thing is that it helps in the growth and development of the human body. Okay, that's why this protein is very important. It also helps in the repairment and maintenance of the body. It regulates the various enzymes and hormones which are present in our body. Next point, protein also help the immune system to fight against the various infection. Either it is caused by the bacteria or viruses. We all know that immune system kill the bacteria and viruses which enter in our body. Okay, so basically this protein help our immune system to fight against the various bacterial and the viral infection. Protein also maintain the osmotic pressure and it help in the regulation of the acid and base in a body and transport the various material inside the body like your hemoglobin, lipoprotein and albumin. So these are the points uh, which express the importance of the protein. Now we all know that the excessive of everything is dangerous. Same case is with the protein. Okay, if you take the protein in an excessive amount, then obviously it create a problem inside the body. That's why we have to take it in a very limited amount. Now we have to see that what is the drawback of intake of the excessive amount of the protein. The first drawback is this protein increases the urea production inside the human body, which is very harmful for the human body. Now, when a protein concentration is increases inside the body, then it increases the urine output. Due to the increment in the urine output, the human body is dehydrated, and it is leads to the dehydration. Third point, if you increase the protein in your diet, then your weight will be increases, and it also create the digestion issues and heart related problems. See, these are the drawbacks of the intake of the excessive amount of the protein. Now, the next is, after the theory, basic theory of the protein, we move forwards towards the principle of the this experiment, because we all know that every experiments are based upon the some principle. So here the estimation of the protein by Lowry's method are also based upon the principle, that is blue color developed by the reduction of the phosphomolybdic and phosphotangenting component in fallen reagent by the amino acid tyrosine and tryptophan in the protein, and color developed by the birate reaction of the protein with the alkaline cupric tartarate, which are measured in the Lowry's method. So, this whole principle, so this whole experiment are work upon this principle. So we are already discussed two part of this experiment, that is basic theory of the experiment and the principle of the experiment. Now we move towards the reagents. First of all, we see that which chemical we are using for performing this experiment and how we form the reagent. So for performing this experiment, we required some chemicals, and the list of the chemicals are sodium carbonate, potassium sodium tartarate, copper sulfate pentahydrate, sodium hydroxide, fallen reagent, and basic bovine serum albumin. With the help of these chemicals, we are going to prepare a reagent. That is, this is our reagent bottle in which we have to prepare the reagent. Then some other materials are also required for performing this experiment, and these materials are weighing balance, micropipette, micropipette tips, this reagent bottles, discard beaker, measuring cylinder, this test tube stand. This is our spatula for the measurement of the chemicals. This is distilled water. Now, with the help of these chemicals, what we have to do, we have to prepare the reagents. So let's start for the preparation of the reagent. So first reagent that we are going to prepare is known as a reagent A. This reagent A is prepared by two chemicals. The first one is your sodium carbonate, that is your sodium carbonate, and the second one is your sodium hydroxide, that is your sodium hydroxide. Now, with the help of these two chemicals, we prepare our reagent A. Now, this reagent A is prepared like 2% of the sodium hydroxide in 0.1 normal sorry, 2% of the sodium carbonate in 0.1 normal of the sodium hydroxide, which means that first of all, we have to prepare the 0.1 normal of the sodium hydroxide in 100 ml. Now, for the preparation of 0.1 normal of the sodium hydroxide, we take the formula from our solution preparation class, which are already uploaded in our YouTube channel. You can visit our channel and see that video. Now, here we simply take 0.4 gram of the sodium hydroxide by the calculation, and it will be dissolved into the 100 ml of the distilled water. Now, put it the aluminum foil into the, now tear the weight. Now take 0.4 gram of this sodium hydroxide pellet. This is very minimum weight, so just weight it very carefully. If you have a powder of this sodium hydroxide, you can use it. But I have a pallet, that's why I'm using the pallet. Now, when I measure the one pallet, its weight is around 0.24. So I'm going to put the another pallet. Now its weight is reaches 0.3. Now take the half of the pallet. Now it is reaches 0.4 gram. Now, first of all, measure the 50 ml of the distilled water with the help of this measuring cylinder and dissolve this 0.4 gram of pallet into it. I'm taking 50 ml of this. Now you see that this is a 50 ml of the distilled water. Now take the reagent bottle in which reagent A is mentioned. That here you can see that reagent A, 2% of the sodium carbonate in 0.1 normal of the sodium hydroxide. Now transfer this 50 ml of the distilled water into it. Take the pallet. Now dissolve this pallet completely. When this pallet is completely dissolved, then add the remaining 50 ml of the distilled water. See, this thing is very important. Like usually student, what they do, they if it is written that prepare a 0.1 normal of the sodium hydroxide solution in 100 ml, then what they do, they take the whole amount of the water and dissolve the chemicals into it. No, you have to divide your solvent into two parts. And first you dissolve your solute in the first part of the solvent, then add the remaining amount of the solvent into it. Here I am dissolving the 0.4 gram of that sodium hydroxide into the 50 ml of that distilled water. When it is completely dissolved, then I'm going to add the remaining 50 ml of the distilled water. You can see that it is completely dissolved. Now okay. Now, before adding this 50 ml, you have to add 2 gram of the sodium carbonate into it, because the sodium carbonate is prepared in 0.1 normal of the sodium hydroxide solution. So, for 100 ml of that sodium carbonate, for 2% for 100 ml, you have to take 2 gram of the sodium carbonate and dissolve into this. Again, you have to tear it. Now, measure 2 gram 2 gram. Now add this 2 gram into the reagent A bottle in which already 0.4 gram of the sodium hydroxide are present. Add it. Now dissolve it completely. It is completely dissolved. Now add remaining 50 ml of the distilled water into it. Your reagent A is ready. This is your reagent A. You can store the reagent A or reagent B for 1 month. Now, after the preparation of the reagent A, our second reagent is reagent B. Now our first reagent, that is reagent A, is ready, which is made up of the combination of the two chemicals, that is sodium carbonate and sodium hydroxide solution. Okay, now we prepare this reagent A by dissolving the 2% of the sodium carbonate into 0.1 normal of the sodium hydroxide solution. Now, after the preparation of the reagent A, we have to prepare the second reagent, which is known as a reagent B. This reagent B is again prepared by the combination of the two chemicals, that is your copper sulfate pentahydrate. You can see that this is a copper sulfate pentahydrate, and the second one is your potassium sodium tartrate. Now, what we have to do, we dissolve the 0.5% of the copper sulfate into 1% of the potassium sodium tartrate. Now, for this, what we have to do, first we prepare the potassium sodium tartrate 1%. Then into it we are going to add the 0.5% of the copper sulfate simply. Now what we have to do, first of all, we measure the volume of the distilled water with the help of the measuring cylinder. Now measure the 50 ml of the distilled water. When you are measuring the volume, like any solvent, you have to measure by putting the measuring cylinder into any surface. Okay, otherwise error occur and you will not get the correct volume of the solvent. That's why I am measuring this solvent, that is your distilled water, by putting the measuring cylinder into the desk. And now you have to measure it like this. Now again it is around 49 ml. So I am going to put 1 ml distilled water more. Now it is 50 ml. This is a 50 ml of the distilled water. Now take the reagent bottle and transfer the distilled water into the reagent bottle. Now measure the 1% of the potassium sodium tartrate. So for this we are going to prepare it for the 100 ml. So we take a weight of the potassium sodium tartrate 1 gram. The detailed video of the solution preparation are already uploaded in our account. You can visit our YouTube channel and see that video. Now for this, first of all, just switch on that weight balance, then just wait for the stability. Now here a 00 gram is showing into the display. Now put the aluminum foil into it, and when the weight is stable, just stir the weight of the aluminum foil and take this potassium sodium tartrate 1 gram. Put it like this. Volume is very less, so you have to weigh very carefully. It is 0.92 gram. So I have to add more amount of potassium sodium tartrate. Now it reaches around, okay, now it is 1 gram. Okay, now transfer that potassium sodium tartrate into the reagent bottle and just dissolve it. Okay, you can see that first I take the 50 ml of the distilled water and I dissolve this potassium sodium tartrate into it. See, usually what the people do, they take the whole amount of the distilled water. Like if they want to prepare 100 ml of the solution, then they take the 100 ml of the that distilled water and dissolve the amount of that weight chemical into it. But it is not the right way. What you have to do, first of all, you have to half the volume of the solvent and dissolve the chemical into the first half of the solvent. Then after that you have to add the remaining solvent. Here this I use the solvent that is your distilled water. Now you can see that it is completely dissolved. Okay, still I'm not going to add the remaining 50 ml of the distilled water because I have to add one more chemical into it, that is your 0.5% of the copper sulfate pentahydrate. So I'm going to take the weight of the 0.5% of the copper sulfate pentahydrate for 100 ml. So for this, what we have to do, we weigh 0.5 gram of the copper sulfate pentahydrate and transfer into this reagent B. Now switch on the weighing balance. When it shows 000 gram, then put this aluminum foil into it and tear the weight of the aluminum foil. Now take the copper sulfate pentahydrate 0.5 gram. Now it is 0.5 gram. Now transfer this 0.5 gram into the reagent B bottle and mix it properly. You can see that I mix it. Now when it is completely dissolved, what we have to do, we have to add the remaining 50 ml of the distilled water and make a volume 100 ml. Simple. Now you can see that it is completely dissolved. Then again measure the distilled water with the help of the measuring cylinder. Transfer this into the reagent bottle and mix it properly. Now our reagent B is also ready. Now, after the preparation of reagent A and reagent B, with the help of these two reagents, that is your reagent A and reagent B, we are going to prepare the third reagent, which is known as a reagent C, or it is also known as alkaline copper sulfate solution. This alkaline copper sulfate solution is made up of like it is prepared by the combination of two reagents, that is your reagent A and reagent B. Simply, now what we have to do, we take this we take the around 49 ml of the reagent A and add 1 ml of the reagent B and make up volume 50 ml. So just take this reagent A and transfer this reagent A into the measuring cylinder and make sure that your measuring cylinder does not contain any amount of the distilled water. Okay, if it is contained, you have to discard it. Okay, now put your measuring cylinder into the desk. Now measure around 49 ml of this reagent A. Now it is around 49 ml. You can see that exactly it is 49 ml. Now with the help of the micropipette, because you have to take only 1 ml of the reagent B. So for the measurement of the 1 ml, you have to use this micropipette of 1000 microliter, that is equal to the 1 ml. Now take this tip, hold it like this. Before transferring it, you have to transfer this reagent A into the reagent bottle. That is your reagent C bottle. Now take the 1 ml of the reagent B and transfer into the reagent bottle. This is your reagent C is ready. That is known as a alkaline copper sulfate. Now our reagent C is ready. That is your alkaline copper sulfate. So you can put it here. Now, after the preparation of this reagent A, reagent B, and reagent C, we have to prepare the fourth reagent, that is your reagent D. Now, this reagent D is prepared by the help of this fallen reagent. What we have to do, we dilute the fallen reagent with the help of the distilled water, and the concentration of the fallen reagent and the distilled water will be same. That means that if you take around 1 ml of the fallen reagent, so you have to take 1 ml of the distilled water. Now here we required in our experiment in a very less amount of this fallen reagent. Now what we have to do, we just take only 5 ml of the fallen reagent and 5 ml of the distilled water. Now, this reagent bottle is for the reagent B. Open it. Now, open the fallen reagent bottle. Don't put the reagent bottle near your nose because the smell can harmful for you. Now, with the help of this micropipette, you can measure the 5 ml of the fallen reagent. 1, 3, 4, and this is 5. Okay, so just discard the tip. Now we have to dilute the fallen reagent with the help of the distilled water. Again, we have to take the 5 ml of the distilled water because the concentration of the foreign reagent and the distilled water will be same. One, two, three, 4, and the last one, 5. Now discard the tip and mix it properly. Now your reagent D is ready. So we already prepared the 4 reagent, that is your reagent A, reagent B, reagent C and reagent D. Now move forward. After that, we have to prepare the stock of the BSA. BSA is bovine serum albumin. This is your bovine serum albumin. With the help of this BSA, we have to prepare the stock of the BSA. Then, with the help of this stock, we have to prepare the working of the BSA. So, for the preparation of the stock of the BSA, we have to take 50 milligram of the BSA and dissolve into the 50 ml of the distilled water. And the storage condition of this BSA or the solution of the BSA is should be at low temperature, which means that you either this bottle of the BSA or the stock of the BSA or the working solution of the BSA, you have to store all the type of the BSA into the refrigerated condition. Now what we have to do, first of all, measure the 25 ml of the distilled water. Okay, with the help of this measuring cylinder, I am measuring the 25 ml of the distilled water and transfer into the reagent bottle. Now switch on the measuring weighing balance and take the 50 milligram weight of the BSA. Put this here the weight. You have to weigh very carefully because the amount is very less. Now the amount is reaches around 50 milligram. Just transfer this 50 milligram into the 25 ml of the reagent bottle. Now mix it carefully. It takes time for the mixing of this BSC solution. So that it is completely dissolved. Then add the remaining 25 ml of the distilled water. Now our stock of the BSC solution is prepared. Now with the help of this stock, I have to prepare the working solution of the BSA. Now for the preparation of the working solution, we take 10 ml of this stock and add 40 ml of the distilled water. Okay, now take it. Now it is 10 ml. Transfer this 10 ml stock into the another reagent bottle. Then add 40 ml of the distilled water into it with the help of the measuring cylinder and make up the volume 50 ml. Now, when we prepare the liquids reagents, we have to make up the volume. And why we do it, the video related to this are already uploaded in our YouTube channel. You can visit our YouTube channel and see that video. Now, all the reagents are ready. That is reagent A, reagent B, reagent C, that is your reagent D, stock of that BSA, working of the BSA. Now, after all these preparation of all these reagent, we have to move forward towards the procedure of this experiment. So, after the preparation of the reagent, we move towards the next topic, that is your procedure. So for performing this experiment, first of all, we required 7 test tubes in which I mentioned the different concentration of the BSA. So in a first test tube, it is written that 0.2 ml of BSA, then 0.4 ml of the BSA, then 0.6 ml of the BSA, then 0.8 ml of the BSA, then 1 ml of the BSA, and at the end it is sample, and in the last test tube it is blank. Means that in this solution, in this test tube, I'm not going to add any BSA, just add the distilled water and the reagent. Now, first of all, what we have to do, we have to take the working of the BSA. We required three type of the reagent only. That is your reagent C, reagent D, and working of the BSA. So first of all, add different concentration of the BSA into the test tube. With the help of the micropipette, first of all, add 0.2 ml of the BSA into the first test tube. So which means that you have to add 2 microliter of the that BSA into the first test tube. So set 200 microliter into the micropipette. See, it is 200 micropipette. Now take the micropipette tip and working of the BSA. Take 0.2 ml or 200 microliter of the BSA and add into the first test tube. Then in a second test tube, you have to add 0.4 ml, that is your 400 microliter. Here I am not going to change the tip because I am using the same chemical, that is the working of the BSA solution. Add 0.4, then 0.8, that is 100 microliter. Avoid the bubble formation. Then 1 ml, that is 100 microliter. And you have to add 600 microliter also, which I forget to add. Zero point 0.2 ml BSA, 0.4 ml BSA, 0.6 ml. This is your 0.8 ml and this is your 1 ml. Now discard the tip. Then take another tip and add 1 ml, sorry, 0.2 ml sample into the 6th test tube. Avoid the bubble formation. Now again, change the tip. Now after that, we have to add the, make up the volume 1 ml of the each test tube. For makeup volume 1 ml, what we have to do, we have to add the different concentration of the distilled water into each test tube. This is our distilled water. Now, in a first test tube, there is already 0.2 ml of the BSA is present. So, what we have to do in that first test tube, we have to add 800 microliter of the distilled water. Take the another tip. Now, the volume become 1 ml. Now, in the second test tube, 0.4 ml BSA is present. So, I am going to add 600 microliter, that is 0.6 ml of the distilled water to make up volume 1 ml. Then in a third test tube, 0.6 ml of the distilled water is present. So we have to add 0.4 ml of the distilled water, that is 400 microliter. Then in a fourth test tube, 0.8 ml BSA is present. So we have to add 200 microliter or 0.2 ml distilled water to make up volume 1 ml. Now in a this test tube, fifth test tube, we are not going to add any amount of the distilled water because here already 1 ml of the BSA is present. So its volume is 1 ml. Now in a sample, 0.2 ml of the sample is present. So I am going to add 0.8 ml of the distilled water into it. Then in a last test tube, we have to add 1 ml of the distilled water because it is blank. Now each test tube have 1 ml of the volume. Now discard the tip. Then after that, we have to add 5 ml of the this reagent C, and then After that, we have to incubate it for 10 minutes at room temperature. Okay. So we are conducting the procedure in which we are already added the different concentration of the BSA and make a volume 1 ml. Now, after making volume 1 ml of each test tube, you can see that. Now we have to add reagent C. This is your reagent C, 5 ml into each test tube, even into the blank also. Now, my micropipette is of 1000 microliter, which means that it is 1 ml. So I have to add 5 times into each test tube. Okay, so let's start. Now I am going to add 5 ml into the first test tube. 1, 2, 3, 4, and 5. Now again we have to add 5 ml into the second test tube. 1, 2, 3, 4, 5. Then 5 ml into the third test tube. 1, 2, 3, and 4, and 5. 1, 3, 4, and 5. Now 5 ml into the fifth test tube. 1, 2, 3, 4, and 5. Then 5 ml into the sixth test tube. 1, 2, 3, 4, and 5. And we have also add 5 ml into the blank one. 1, 2, 3, 4, and 5. Now we have to incubate the test tube for 10 minutes at a room temperature. Then after that, we have to add the reagent D into the each test tube. Okay, so we have to incubate it at least 10 minutes at a room temperature. Now, after the incubation of the 30 minutes, you can see that the slight changes in the color of the test tube, and that color, the concentration of the color are depend upon the concentration of the BSA. Like in the first test tube, you can see that the concentration of the BSA is very less amount, that is around only 0.2 ml, and in a in a fifth test tube, the concentration of the BSA is around 1 ml. So the difference between the color are clearly visual. Okay. Now, after 10 minutes, we have to add the reagent D into each test tube and then incubate it for 30 minutes at a room temperature. Okay, and the concentration of the reagent D is around 0.5 ml, that is 500 microliter into each test tube. So, take the value into the micropipette, you can see that it is 500 microliter, which means that 0.5 ml. So we have to add it into the each test tube. In a first test tube, then add into the second test tube. I'm not changing the tip because the chemical is same. Then into the third test tube, then 0.5 ml into the fourth test tube, then 0.5 ml into the fifth test tube, then 0.5 ml into the test tube in which the sample is present, and 0.5 ml into the blank one. Now what we have to do, we have to incubate it at 30 minutes at a room temperature. Then after that, we will take the absorbance of the that solution at 660 nanometer with the help of the spectrophotometer. First of all, what we have to do, we set the wavelength around 660 nanometer. Then we take this and take the absorbance. So we will do this after 30 minutes. Now, after the incubation of 30 minutes, we get this color. You can compare the color of the test tubes as a concentration of the BSA increases. The color of the that the color of the test tube will also increases. Now, what we have to do, we have to take the absorbance with the help of the spectrophotometer, and this is your cuvette. What we have to do, we simply transfer this solution into the cuvette and put this cuvette inside the spectrophotometer and see the reading into the display. This is how we take the reading with the help of the spectrophotometer. And we will start with the blank one. First of all, we take the reading of the blank. Then after that, as the concentration increases, we increase the we take the reading. Now, first of all, take the black one. You can see that there is no color development take place in the black one because there is no there is no amount of the BSCs added into this cube that into this solution. And this is your cuvette. Cuvette have two sides. The one is your transparent. You can see that this is a transparent side, and the another one is your opaque side. Now what we have to do when we put this cuvette inside this spectrophotometer, we have to ensure that that opaque side will be in front of us. Now fill this. With the spectrophotometer and put it like this. Now note down the reading. Reading is around 0.0010. So you have to note down the black reading, because with the help of this reading we have to plot a graph, and then with the help of the formula and so we will find out the that concentration of the protein in particular that soft drink. Now take out this, discard this, then wash with the distilled water so that the residue of the blanch will not be there. Then take the 0.2 ml of the BSA. Now transfer this into the cuvette and then just dry this cuvette with the help of the filter paper. Just wipe it. And again put this cuvette inside the spectrophotometer and ensure that the opaque side will be in front of you. Simply. Now open this spectrophotometer and put it and wait for the reading. One more thing, this wavelength of the this experiment will be around 660 nanometer. So I am taking the absorbance at 660 nanometer and I just set that reading with the help of this black knob. So here I get the reading around 0.028. When the concentration of the BSA is 0.2 ml, then we get the absorbance 0.028. Then take out this, discard this, then wash with the distilled water. Every time we have to wash it with the help of the distilled water. It is very important. Then take the 0.4 ml. Again, wipe it with the help of the filter paper. Open this, put it into the spectrophotometer. Note down the reading. Wait for the, when the fluctuation occur, you have to wait. When it is stable, then note down the reading. Okay, at 0.4 ml, we get the 0.056. Then again, take out, discard. Now, wash it with the distilled water. Then take 0.6 ml. Wipe it with that filter paper, which is very important. We have to wipe it every time. It will not damage your machine. Then put it into. Now, this time we get the 0.084. Then again, remove it, discard, wash it with the distilled water. Then take the reading that is 0.8. Transfer it into the cuvette. Now dry it with the help of the filter paper. Then put it into the spectrophotometer. Then note down the reading. It is around 0.112. Then take out, discard. Wash it with the distilled water. Now take 1 ml. This is a 1 ml. 1 ml of BSA. Again, wipe it with the help of that filter paper. Open the spectrophotometer. Put it into the machine and wait for the reading. Now this time we get the 0.140. Now we do all the concentration of the BSA. We take the reading of all the concentration of the BSA and the blank one. Now the remaining is what? The remaining is our sample. So we have to take the sample reading also. Now wash it with the that distilled water. Then this is your sample. Okay. Then transfer it into the cuvette. Wipe it with the filter paper. Then put it into the spectrophotometer. Every time you have to ensure that opaque side will be in front of you. Okay. And transparent side will be this side. Okay. Now take the reading. It is around 0.016. Now you note down all the reading, and after noting down the reading, we have to draw the graph in between the absorbance and concentration of the BSA. Then with the help of these formula, we calculate the concentration of the protein present in a soft drink. Now, after putting the value of the absorbance and the concentration of the BSA into the graph, we get the slope by using the formula, that is A2 minus A1 divided by C2 minus C1. A1 and A2 is the absorbance values and C2 and C1 is the concentration of the BSA. Now simply when we put it into the formula, we get the slope that is around 0.140. This is a slope. Then we get the A corrected by using the formula sample absorbance minus blank absorbance. Then we get the values, and that value will be divided by the slope. For calculating the protein concentration, which is equal to the A corrected divided by the slope, and A corrected will be the subtraction of the sample and blank. We subtract the sample blank from the sample, and we get the protein concentration, which is around 0.042 microgram per ml. So this is a concentration of the protein that we get of our sample by using the Lowry's method, and this is a whole procedure that we do. I hope you will understand the procedure. But if you have any query related to this experiment, you are free to ask me in a comment box. Or for a further detail, you can follow the ITLS Academy on different platforms, that is Instagram, Facebook, Twitter, YouTube, WhatsApp, and LinkedIn. And subscribe our channel ITLS Academy on YouTube and get our app from Google Play. You can also ask your query to our helpline number and visit our website, that is www.itlsacademy.com. Thank you for watching. Please like, share and subscribe our channel.